Guys, another Monday, another homework. What's worse, the homework is math. I don't even get the lesson. I need help. I need help from my friend. I will call Alex. I need Alex. Alex, answer me. Answer me. I need you. Alex.
Hey, what's up? Where you calling
I
me?
need help. I need
Is it
help.
math? If it is, then I cannot help you.
Why? You also don't get it?
Yep, I also called Marian, and you know what they told me? You're just gonna sleep and you know the answer.
Always sleep, so it's not something new. Hi. Anyways, how can we answer this if we both don't know how?
I just overheard this, but there are 3 people that could actually help
Is
us.
that the 3
You
MATHketeers?
know them?
Of course! I always need help in math. And I already asked help to them several times. So, do you mean we should ask help to them?
Do you really need to ask them?
Chill. Chill. I call them so that they can help us now.
Okay, just update me.
Okay, here we go. 3 MATHketeers, help us!
You called for us?
Yes, I really need your help, guys.
Tell us the problem.
So the lesson is limit of transcendental function, which are, what's that 3 is exponential, logarithmic, and S1 is trigonometric. I just need you guys to teach me how to do it.
Noted, MATHketeers 1.
We'll start at exponential. With finding the limit of a transcendental function with exponentials, it often involves these simple steps. First is the direct substitution. Just try to plug in the value that the limit has approached. And if you get a defined answer, then that's your limit. Second, which is the L'Hopital's rule, if you get an indeterminate form like 0 over 0 or infinite over infinite, just differentiate the numerator and the denominator. Then, try the limit again. Third, the algebraic manipulation. Just try to simplify the function by factoring, canceling terms, or using trigonometric identities. Fourth and the last is the squeeze theorem. Find 2 functions that squeeze the original function, and if their limits are equal at that point, the original function's limit is also equals. Well then, that's it.
Oh, so that's it? What about logarithmic?
In solving the limits of logarithm functions, you just need to observe where the x approaches is. If it is approaches to real numbers or if it is approaches to infinity. Well, if it is approaches to real numbers, you just need to use direct substitution. For example, limit of log 3x as x approaches to 9. If we are using the direct substitution, then substitute the 9 to x. And input this in calculator, you get the answer, which is 2. Easy, right? Then what if the x is approaches to infinity? Remember these theorems. So, if b is greater than 1, follow these theorems. But if b is greater than 0 but less than 1, then follow this theorem. So, b is greater than 1. Limit of log bx as x approaches to positive infinity, then the answer is positive infinity. But limit of log bx as x approaches to 0 to the right, then the answer is negative infinity. But what if b is greater than 0 but less than 1? Limit of log bx as x approaches to infinity it will be negative infinity. Then the limit of log bx as x approaches to 0 to the right, the infinity will be positive. Remember these theorems and you'll know the answer.
Then, trigonometric.
Trigonometric functions or circular functions are sine, cosine, and tangent. They are used in the analysis of periodic behavior. These functions also show time periodicity and are used in nearly in all branches of science and application like physics and engineering and signal processing. Limits of trigonometric functions. If a is any number in the domain of the corresponding trigonometric functions, then we do this. The limit of sine x as x approaches to a is equals to sine a. We'll just substitute the value of a to x. The limit of cosine x as x approaches to a is also equal to cosine a. To understand this, I'll give one example. The problem is the limit of cosine 2x as x approaches to pi over 2 is equals to, we substitute the value 2 over pi to x, which will be cosine 2 times pi over 2. Simply 2 pi over 2 will cancel both of the 2, and that just leaves us with pi. Now, the limit will be the limit of cosine 2x as x approaches to pi over 2 is equals to negative 1 because cosine pi is equals to negative 1. Now, I will show you a theorem called squeeze theorem. The squeeze theorem can be used when a trigonometric function is bounded between two other functions whose limits are known. For example, f of x is less than or equal to g of x, which is less than or equal to h of x. If the limit of f of x as x approaches to a is equals to the limit of h of x as x approaches to a is equals to L. So that means the limit of g of x as x approaches to a is also equal to L. So we can use the squeeze method solving this problem. The problem is the limit of x sine x over x as x approaches to a is equal to, we can use the squeeze method by noting that cosine x is less than or equal to sine x over x, which is less than or equal to 1. Because we know that cosine x and 1 both approaches to 1. So the limit will be the limit of sine x over x as x approaches to 0 is equals to 1. That's all for trigonometric functions. Thank you.
Thank you! I finally get it! Thank you very much, guys. You guys are always been helpful to me.
No worries.
No worries.
Now, I can call Alex to show how to do it. Oh, it's Salazar. Hey, what's up?
Hey there. So, can I
Oh.
copy your answer?